Yeah. So sound waves can be classified based on frequency into three categories. Infrasonics, any sound wave which has frequency less than 20 Hz. Sonics, normal audible sound whose frequency lies between 20 Hz to 20,000 Hz. And ultrasonics, which is any sound whose frequency is above 20,000 Hz. Now this sonics is the sound which is audible to the human ear. This again, based on perception, we classify it as music or noise. Music is anything which has a regular periodic change in loudness, in frequency, in tune. Anything which is irregular and abrupt is called noise. So that is how sound is broadly classified. So a quick recap. Sound wave can travel either longitudinally or transversely. Any wave for that matter, light wave, sound wave, matter wave, can travel longitudinally, meaning it moves in a horizontal direction, or transverse, meaning the wave itself moves up and down like this vibration, but the energy moves horizontally. And the velocity of sound wave is given by the formula root over E by rho, where E represents the Young's modulus and rho the density of the medium. So velocity of a sound wave depends on the medium it is traveling through. So sound has a different velocity in vacuum, in glass, in metals and so on, and this velocity depends on what medium it is traveling through as root over Young's modulus by density. Now some of the important physical characteristics of sound are pitch, loudness and quality or timbre, which we are going to be looking at. So the first and most basic characteristic is pitch. 1 minute. Yeah, so I was saying the first characteristic of any sound wave is pitch. Pitch is one of the most basic characteristics. Even when we're normally talking about sound wave in layman's terms, we say you have a very high pitch voice or this instrument produces a high pitch note. What it means is that the frequency of that sound wave is very high. Now pitch is not the same as frequency, it's not directly equal to frequency, but it is directly proportional, meaning a high frequency sound is what you describe as high pitch and a low frequency sound is what you describe as low pitch. But pitch is not equal to frequency. The formula is pitch is equal to a constant times frequency, that constant being 2 to the power of 1 by 12. This relation was discovered by Pythagoras. So when we say pitch, what we generally mean is whether the voice is very shrill or it's mellow and soft kind of. So it's not exactly loudness, and it's difficult to sort of explain pitch in words, but when you hear a sound you sort of know this is a high pitch sound, this is a low pitch sound. So what makes a sound high pitch or low pitch is its frequency, that is how fast the particles in that sound wave are vibrating. So that is what pitch is about. And again the formula for pitch is 2 raised to 1 by 12 times the frequency, and our ear identifies frequency with a resolution of 2 Hz, meaning resolution is like the least count of an instrument, which is the smallest value that instrument can measure precisely. So if you take a ruler, when we say its least count is 1 millimeter, it means anything smaller than 1 millimeter cannot be measured by that ruler. Say you have some 0.005 mm, you cannot measure that by ruler, but if it's 1 mm and 1.5 mm, that can be measured. So similarly, the smallest frequency interval our ear can measure is 2 Hz. Now don't confuse this with the 20 Hz to 20,000 Hz, that is the range it can measure. But the smallest difference between two frequencies that the ear can discern is 2 Hz, meaning I have a sound at 20 Hz and another at 22 Hz, then my ear can differentiate between both. But if I have 20 Hz and 20.5 or 21 Hz, my ear cannot differentiate. So that is what this statement means, resolution of 2 Hz. So any questions so far?